This question came up for H2 Math Paper 1 this year, and JC1 students who are going to take your paper next year, beware, this is something new in the syllabus, which is your recurrence relations. But before we go into this video, I just want to mention that next year, I will be opening a JC class for both J1 and J2. So if you want to get tutored by me personally at my math tuition center and make math make sense for you, WhatsApp this number over here and I'll send you all the details that you need to know for my classes. Now, let's dive right into this question over here that came out. And I'm going to be going very in-depth into this, and I won't rush because getting an answer is one thing, but another thing is to really understand how the answer is being derived. So over here for this question, we are given a sequence, and a sequence is just an ordered set of numbers. So you just know that it's just an ordered set of numbers where each number is somehow related to one another. And over here we are given this relationship over here. So typically for a recurrence relation, we will have a base case. So in this case, my first term is A, and then every other term, the second term depends on the first term, the third term depends on the second term, and this is illustrated by this over here. So for A over here, we want to find U2, right, the second term. And we know that U2 is dependent on U1 because it can be written as U1 plus 1, as you can see over here. That means this is just 3U1 plus 5, and that will give me 3A plus 5 because U1 is my base case and that is my A over here. So that's the answer for U2. Now for U3, it will just be the same thing, but now it's depending on U2. So it's U2 plus 1, right? U3 depends on U2. And what's the value of U2? The value of U2 is 3A plus 5. And therefore over here, we'll write 3 bracket 3A plus 5 plus 5. And when you compute the whole thing, you get a final value of 9A plus 20. So this is a brand new addition to the H2 Math syllabus starting from this year onwards. And I believe that, while it's not something that is very new because it actually came out before in previous versions of the syllabus, they actually took it out for some period of time. I hope that, you are able to understand this because it's a very useful life skill to have, right? Being able to understand recursion. Now, for B, now we have a sigma notation question, and we are given that the sum of the terms from r equals to 1 to r equals to 4 is 110. So how do we actually read this, right? We can read this as the summation of the terms from r equals to 1 to r equals to 4. And that will be u1 plus all the way up until u4 will give me 110. Now, u1 over here, we know it's a, right? u2, we know it's 3a plus 5. u3, we know it's 9a plus 20. Now, all we got to do is to figure out what's u4. And we know that u4 is dependent on the previous case, which is u3. So it's u3 plus 1. And therefore it will be 3 bracket u3 plus 5. And now we just got to put this inside here, right? It depends on the previous case. And this over here will give me 3 bracket 9a plus 20 plus 5. And this will end up to be 27a plus 65. So all we got to do now is to sum all of these four terms, right? That's what the summation sigma notation there means. Therefore, a plus 3a plus 5 plus 9a plus 20 plus 27a plus 65 in the end ends up to be 110. And then from here, we can just solve for a, right? We add up all the a values together. We get 40a plus 70 gives me 110, and therefore 40a is, we add up all the a's together, we get 40a plus 90 gives me 110, and therefore 40a is 20, and therefore a is 20 divided by 40, which gives us the final value of half over here. And that's basically the solution to the first part of the question, and that is question 1 for the H2 Math paper in 2025. So this is the start to many more recursion questions to come, and it's all in your first chapter of sequences and series. Now, over here, I have a arithmetic sequence, and we immediately know that this is an AP, right? And what an arithmetic sequence basically is just a sequence of numbers whereby the difference between each number is just a constant. So for this AP, right, for part A, I can let UN be the general term, so general term of this AP. And we know that the general term of an AP is UN equals to A plus N minus 1D. Now, what is this? A over here is the first term, right, U1, because every single term in the sequence all starts from term 1. And over here, D is the common difference, so common difference, whereas N minus 1 is the number of times I jump forward to reach this new term. So for example, U2 will just be A plus 1 times D, U3 would be A plus 2D, right? To get to U3 from U1, I need to jump forward 2 times, and that's why we have a N minus 1 to count the number of times I jump. Now, they say that the sum of the first 20 terms is 65, and what's the formula for sum of first n terms? Sn. So the formula for the sum of the first n terms is basically the number of terms divided by 2 times the first term plus the last term, right? Or some of you might remember it as the number of terms divided by 2 plus 2a plus n minus 1d. But over here, honestly, these two formulas are actually equivalent because Hence, this can be broken down into a, which is the first term, plus a plus n minus 1d, and this over here will be the last term. So actually these two are equivalent. And the reason why we divide by 2 over here is because we want to find the number of pairs. So this and this over here forms one pair, and we want to find out within the first n terms how many pairs are there, right? For example, 1, 2, 3, 4, this forms one pair, this forms one pair, right? So in total there are 2 pairs even though we got 4 numbers. So for this formula over here, we want to find the sum of the first 20 terms. So S20 would be 65, right? And we know in the first 20 terms, there are 20 divided by 2, which is 10 pairs. Now the first term, right, would be A plus, now what's the last term going to be, right? The last term is going to be A plus 20 minus 1d over here, and this will actually gives us 65. So if we expand out the whole thing, we get 10 bracket 2a plus 19d gives us 65. So if we expand this, we get 20a plus 190d gives us 65. So actually this is the first equation that we can use. Now the next equation that we have is the sum of the next 8 terms. So from the 21st term all the way until the 28th, right? So if I write it out like that, right, we know that 1 dot 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 up until 20, this forms S20, right? The sum of the first 20 terms. Now 21, 22, 23 all the way until 28. This over here is actually S28, but we don't want S28 because we only want this portion over here. Therefore, we can actually describe this portion over here as S28 minus away S20, right? We take the sum of the first 28 terms, then after that we minus away the first 20 terms. So we know for the second equation, S28 minus S20, right, as given by the question, is negative 30. Therefore, S28 can be also written as and therefore S28 can be written as S20 minus 30, which is S28 equals to S20 being 65 minus 30, we get S28 is 35. And we can reuse the same formula over here because now we express it in terms of the first 28 term. So 28 divided by 2 bracket 2a plus 28 minus 1d gives us 35. And from here we get that 14 times 2a plus 27d gives us 35. Expand this, you get 28a plus 378d gives you 35. So now you have two simultaneous equations. And if you key these two simultaneous equations into your GC, you will solve that a is 8 and the common difference d is negative half, and this is the final answer to the first part over here, right? So this is a very simple sequence and series question that I think is very standard, especially if you're a J1 student. This question is actually really standard. Now for the part B is also a very standard question, which is how do you prove that something is geometric? Now just as a recap, whenever it comes to any sequence, right, not necessarily everything is an AP or a GP, right? It can be a mix of both, or it can be just something very different. But over here, we want to specifically show that it's a GP. Now, what is so unique about a GP? The unique thing about a GP is that between each term in the sequence, the difference is actually a constant multiple. So this means that if we take un plus 1 divided by un, right, n plus 1 being the term after un, the difference between these two terms should only be a constant multiple. And therefore, when I divide them away from each other, I should get a constant that does not contain n, right, independent of n. So you see over here for un, right, how do we actually find out what's the constant term, right? If un is e to the power of k bracket n plus 1, that means un plus 1 will be e to the power of k bracket, replacing this n, we get n plus 1 plus 1, which gives us e to the power of k bracket n plus 2. Now, if we take these two and divide them away from each other, right, un plus 1 divided by un, we get e to the power of k n plus 2 divided by e to the power of k bracket n plus 1. And if you expand this using indices, right, e to the power of k n plus 2 minus k n plus 1, right? If you minus away the powers away from each other, you realize that in the end, you get e to the power of k n plus 2k minus kn minus k, which gives you e to the power of k. And therefore, this e to the power of k over here is the constant difference between these two terms, and it's the constant multiple. And therefore, for the explanation, we just need to write something very standard, which is, therefore, since un plus 1 over un is a constant independent of x, comma, then we can conclude that it's a GP. And that's how we actually tackle question 2 over here. Now over here, this question, for part A, is a fairly straightforward question. We are asked to find the modulus, which is the length of the complex number, right, the length, and the argument, which is the angle measured from the positive x-axis in the anti-clockwise direction. So over here, we can see that z over here is given by root 3 plus I over root 3 minus I. Now, whenever we want to find the modulus of a number, right, given in the new syllabus where there's no more trigonometry, whereby there's no more questions involving trigo or expo in complex numbers, we will always just rationalize the denominator to make sure that we are able to find out what's the real coefficient for each of the real and imaginary components. So over here, I'm just going to multiply it by its conjugate surd, so 3 plus I root 3 plus I, right? And then you realize that when you expand the numerator over here, you end up with a square plus 2ab plus b squared, right? And in the denominator, we essentially end up with 3 plus 1, which is 4. So over here, we end up with 3 plus 2 root 3I minus 1 over 4. And therefore, when we expand the whole thing over here, we get 2 plus 2 root 3I over 4, which we can then split into the real and imaginary components of this complex number, which will be half plus root 3 over 2I. Now, to find the modulus, which is essentially the length, is actually fairly straightforward, right? It's just your Pythagoras theorem underneath it all. So modulus z would be square root of a square, which is half square, plus your root 3 over 2 square, right? And when you key this into your calculator, you get a value of 1. So the answer to the first part of here is actually 1. Now for the next portion, argument of z. How do we find the argument of a complex number? We will always need to draw the Argand diagram. So imaginary is here and then the real axis is here. Now given that the coefficient of the imaginary is positive, it's somewhere here, right? Root 3 over 2. And then for the real component, it's half. So it's again along the positive x-axis. So the number is somewhere here, right? Over here. And this over here, this theta will be my argument. So therefore, the argument of z would just be just your tua kaso, because over here you can see that my opposite length is root 3 over 2 and then my adjacent length, right, is half. So it will just be tangent inverse opposite over adjacent, which will be tangent inverse root 3 over 2 divided by half, right? And when you key this into your calculator, you get a value of pi over 3. And that's the answer to this question over here. Now for the next portion in B, we have a new point, which is basically the original point A, just that now it's rotated anti-clockwise. So what this looks like is something like that, right? We can see that A is originally over here, and then it shifts anti-clockwise by pi over 2, right? 90 degrees, to end up somewhere over here where it's B. Now take note that the modulus of B is still 1, it's just that now the argument is different. But now, in terms of z, how do we actually represent B? So we can see that for part B, we can see that the argument of B now is essentially the argument of z plus another pi over 2, right? And over here, if you recall, pi over 2 is essentially the argument of I, because if you draw your Argand diagram again, imaginary and real, for a complex number of I, so I is somewhere over here, where here is 1, the argument is pi over 2. So I could therefore rewrite this as equals to argument z plus argument of I, which will give me a combined total of argument iz. So therefore, when we combine these two together, we actually get argument iz. And therefore, the equivalent of B is actually iz. So we can say that B in terms of z is iz over here. And that's the final answer to the next portion over here. Let's just jump right into this question. Okay, so first thing is, they want us to find dy dx, and just don't mind my handwriting over there, right? So how do we find dy dx? Now, our y is 3x plus 10 over root x plus 1. So fundamentally, this is u over v, right? So we've used our quotient law. We know it's vu prime minus uv prime over v squared. So all we got to do is to copy this pattern and just differentiate accordingly, right? So we'll have x plus 1 to the power of 0.5, so I'm just going to put a 0.5 over there, times the differentiated, which is 3, minus away 3x plus 10, then I differentiate the denominator. So here I'll bring down half, here will be x plus 1 to the power of negative 0.5, and then I differentiate in one more time, and then the whole thing over here will be over x plus 1 to the power of 0.5, then over here I square it, right? And then from here we will just expand the whole thing, but just to save your time, your final answer that you should have derived for this question over here, when you fully simplify it, it should be 3x minus 4 over 2 bracket x plus 1 to the power 1.5, right? If you just further simplify this all the way, and also if you bring this down over here, right? So this is how we actually simplify this. Now, they say find the x coordinate of the turning point of the curve. So we know that when it comes to any turning point on the curve, right? For instance, let's say this point over here is the turning point, right? Because at that moment of time, the curve actually changes its direction. So we know that for all turning points, the gradient over here is 0, right? The gradient is flat, and that's why we say that over here the dy dx will be 0 specifically at this point over here of the value of x. And therefore we will say that for all turning points, we can confidently say that my dy dx will be 0. So when I have a fraction equals to 0, right, we know that the denominator cannot be 0 because the whole entire fraction will be undefined. However, the numerator will be the one that's 0. So if I have 3x minus 4 over 2 bracket x plus 1 to the power 1.5 equals to 0, we know that the numerator is 0, and therefore this equals to 0, and therefore x is 4 over 3, which is the final answer to the first portion over there, right? So that's the first answer. Now for the next answer, a lot of students actually miss out on the fact that they need to use second derivative, right? Which means you can't use first derivative test. So for the second part, it's very straightforward. You just need to differentiate it one more time. So we can just say that by our second derivative test, so derivative test, right, all we need to do is to find our d square y dx squared, and in order to do that, we just need to go and differentiate our dy dx one more time, which means that we just need to differentiate our dy dx of 3x minus 4 over 2 bracket x plus 1 to the power of 1.5 over here, and then we close the bracket over here, right? And then when you further differentiate this all the way, right, just to save you the time, I'll jump right into the final answer. So at the end of it all, you actually don't really need to fully expand this, because all we need to do is to just find out what is the nature of the stationary point, right? But of course, it'll be good if you simplify it all the way, but just for 3 marks, I wouldn't do that, right? At this point over here, it's good enough because over here we can just sub x equals to 4 over 3 into our d square y dx square, and our d square y dx square value will get a value of 0.42084 ... which is positive. Now, how do we intuitively remember that this over here is a minimum point? So I just want you to take a look at this graph over here, right? At this graph over here. Imagine this over here is my dy dx graph, right? My dy dx graph. And my dy dx graph also has a gradient, right? Along this graph over here, there are many different gradients. And we can see that the gradient of the dy dx graph is increasing, which means that the gradient of dy dx is going upwards, which is a positive gradient. And therefore, d square y dx square should be positive as well for a minimum point. And therefore, we can conclude that x equals to 4 over 3 is a minimum point. And that's the final answer to this question that came out for the 2025 paper 1 H2 A level math. If not, let's just jump right into this question over here. So right off the bat, right, we're asked to solve this inequality. And of course, the first thing that you probably think of is, substitution method, right? To make this entire equation look a bit simpler. But first thing, of course, when it comes to inequality, the first thing that we will always do is to bring every inequality to the left-hand side so that one of the sides equals to 0, right? So I'm just going to shift everything over. So ex minus 2e minus x minus 1 is bigger than or equals to 0. Now, to put it in a form that is simple, easier for me to understand, I'm just going to let ex be y. So now I have y minus 2 over y minus 1 equals to 0. Because take note over here, this can be written as 1 over ex, which can be written as 1 over y, right? Now over here, this is bigger than or equals to 0. Now, how do we actually solve this? Well, we need to put it into a quadratic equation. But the only way to get it into a quadratic equation is if we times y on both sides, right? If we times y on both sides, here will be 0, and then here will be y squared minus 2 minus y. But then the question becomes, what happens to this sign over here? Do we flip it or do we not flip it? Because whenever it comes to multiplying anything on both sides, we always need to be very careful. And the answer to that comes down to what you're actually multiplying on both sides. So if you take a look over here, right, you can see that ex is y. So y equals to e to the power of x. And if we were to actually sketch out, right, the e to the power of x graph, if you use your GC as sketch, you have y equals to ex over here. You can see that for all real values of x, right, for every single real value of x, the value of e to the power of x will always be positive. So we know that e to the power of x is always bigger than 0 for all real values of x. And since it's always bigger than 0, when we multiply y on both sides, it doesn't flip the sign, because we are essentially multiplying a positive number to both sides. So we can very safely say that y squared minus 2, or rather minus y minus 2, is bigger than or equals to 0. Then of course over here, when we factorize it, right, over here, we will essentially get y minus 2, y plus 1 is bigger than or equals to 0. So now we can just view this whole thing as a quadratic curve first, right? In the quadratic curve, we know that over here, this will be a value of -1, and this over here will be a value of 2, right? And since we are taking the positive bigger than or equals to 0 portion, we'll take this portion and this portion. And just take note that since it's inclusive of 0 as well, these two over here are circled. That means we will also take into account these two. So therefore, y is lesser than or equals to -1, or y is bigger than or equals to 2. But of course, we're not solving for y, we still need to sub back x in. So now subbing in ex, so ex is lesser than or equals to -1, or ex is bigger than or equals to 2. But just take note over here, right? We know that ex must be bigger than 0. So we will have to reject this as an answer. And therefore over here, what's the value of x? To find the value of x, you just need to ln both sides. And you get a value of x is bigger than or equals to ln 2 as the final answer to this part A over here. Now for part B, they say hence, find the solution to this, giving your answer in exact form. So when we actually sketch this graph out, right, using our GC, right, because since over here there's a modular sign, what a modular sign basically entails is that some portions of the graph will be negative, some portions of the graph will be positive, and it is up to us to figure out which portion is negative and which portion is positive. And the best way to do this would be to sketch your GC. So if you sketch on your GC over here, right, you'll realize that the graph looks something like this, right? It looks something like this, whereby over here, this is ln 2. And right here, okay, let me just redraw it nicer. When you redraw this on your GC, you essentially get this. You get something that looks like this, right? Whereby essentially here is 0, here is ln 2, and here is 1. So what the question wants is that the question wants the area over here and over here, right? Because they are essentially asking us what's the integral of 1, 0, and then this is your entire equation over here, right? Which is e minus x minus e2 minus x minus 1 dx. So they want from 0 to 1, but then of course, because of the modular sign, we're going to take everything as the positive region. So if we want the area of portion A, it will be negative modulus 0 to ln 2, right? And then of course, this will be our equation over here. So this is ex minus 2e minus x minus 1 dx. Now for the second portion, since it's already above the axis, we don't need to put a negative sign on it to flip it. So over here will just be integral of ln 2, 1. Right, and then here is ex minus 2e minus x minus 1 dx. And then from here, we can just go and integrate both sides. So over here, we'll get ex minus 2e minus x over minus 1 minus x. And then don't forget to put a negative sign in front because we are initially taking a negative region and therefore we need to multiply a negative to it to make it positive. Right, and then here will be 0, here will be ln 2, right? And then since the equation over here is exactly the same, it will just be ex minus 2e, or rather 2e minus x over minus 1 minus x, and then my upper limit is 1, lower limit is 2, right? And then when you sub in these values into your equation and further simplify it, you should eventually get a value of ex plus 2 over e plus 2 ln 2 minus 4 as the final answer to this. I'm just going to reiterate, I'm just going to skip past that because that is just subbing in the values and making sure you don't make any careless mistakes. But this is the broad idea, the way to actually tackle this question. And since our answer must be in the exact form, we will leave it in exactly the exact form. So this is how we tackle H2 Math Paper 1, question 5 over here. Now let's look at this question over here. So this question over here, feel free to pause to read it, has quite a bit of context. But essentially, it's just about your C14 proportion inside a plant, right? And it's given that when time is 0, so when t is 0, my mass is essentially m0 over here, right? And it's given that when t is 5730, my mass become half of m0 because they say that the mass of the plants decreased by 50%. So it has to decrease by 50% from somewhere, right? And the somewhere is the m0. So we are given that the equation over here starts off as dm dt is negative km. And we are asked to solve the differential equation to find the value of k. So first thing is, if I want to solve a differential equation, I need to first find out what's the general solution. And the general solution is the one that includes the c, right? The plus c, the arbitrary constant. Now looking at this, first thing is that I see that it's with respect to t, but my variable is m. Now that cannot be the case, so what we'll do is that we'll use the reciprocal of it, which means that we will flip this to become dt dm equals to negative 1 over km. Right, so these two are actually equivalent because we're just taking the reciprocals on both sides. Now since it's with respect to m and my variable over here is still m, I can then integrate this. So t would be in the integral of negative 1 over km dm, right? And to make things easier for myself before I begin, I will actually first multiply this scalar multiple over to the other side so I do not get confused with it, especially when a plus c comes in later on. So I'll multiply the negative k to the other side first, and over here I'll get negative kt is 1 over m dm. So integrating 1 over m, I'll get ln m plus c, right? And since we know that the mass, right, can never be negative, so we can say that since m will always be bigger than or equals to 0 possibly, right? We know that modulus m will just be m, right? Because it cannot be negative. So we can just say negative kt is ln m plus c. So now to make m the subject, right, I minus the arbitrary c over first. I get ln m, and then I make e to the power of negative kt minus c equals to m, right? I change from log form to expo form. So m equals to ae minus kt over here, where a is just a representative of e minus c, so that we don't have to keep writing e minus c all the way. So this is our equation here, right? And our job now is to find the value of k. So to find the value of k, we must first find out what's the value of a over here, right? And recall at the start of the question, we know that when t is 0, m is m0, where m0 is just some specific value. So we can just sub this in, and we get m0 is a e to the power of 0. So a times 1 gives me m0, and therefore a is just m0. So I can say from here that my m value, or rather, I'm just going to zoom in here, my m value is m0e minus kt. So now I only have one other unknown left, which is my k over here. So the other thing that we know is that when t is 5730, m is half of m0, right? That is what is mentioned at the question at the start. So bringing this to the top over here, how do we actually solve this? So we sub that values in first. So half m0 is m0e minus 5730t. I can then proceed to strike this out. I have half is e minus 5730t, right? If I ln both sides, ln half is minus 5730t ln e, which is just 1. And we know that t can be written as ln half over minus 5730. But just take note that we can further simplify this even more, because this over here can be written as 2 to the power of negative 1, of which we can then bring the negative forward as a coefficient to get minus ln 2 over minus 5730. Then the minus will strike each other out, and therefore my final answer is t equals to ln 2 over 5730, and that's the final answer to the first portion of the question. Now for the next portion of the question, they say a dead plant has 20% of its original mass, right? Determine to the nearest 100 years how long ago the plant died. Or essentially they're asking what is the value of t when m is 1/5 of m0, right? Because 20% of its original mass over here is essentially the same thing as 1/5 of m0. So all we need to do is to just sub 1/5 m0 into the equation and then solve for t. So we can just sub this into the equation. We have 1/5 m0 is m 1/5 m0 is m0e minus, just take note that now we know the value of t, so it's ln 2 over 5730t, right? And now to solve for t is fairly straightforward. We know that we can strike out the m0 over here, because m0 is just a constant. 1/5 is e minus ln 2 over 5730t. Now when I ln both sides over here, I get minus ln 2 over 5730t, and therefore t over here, when you actually divide it over, right, 1 over 5 divided by negative ln 2 over 5730, you get a final value which is nearest 100, which is 13300 to the nearest 100, right? And therefore the final answer is 13300 years to the nearest 100, and that's the final answer to this question over here. Now let's look at this question. Now for the first part over here, I think it's fairly straightforward to show it, right? You just need to differentiate it. So let's say we start from the left hand side, d over dx, x ln x minus x, right? This over here is our product law. So we have x, differentiate ln, we get 1 over x, then we plus ln x over here, we differentiate x over here is 1. Right, after that, when we differentiate minus x, we get minus 1. and therefore here will be x over x plus ln x minus 1, which is 1 plus ln x minus 1, which is just ln x, which is the right hand side. So over here we show, right? So the first part is actually very straightforward to show. Now for the next portion, this is where they want us to find the volume of the solid being generated when the region R, which is a region that is bounded by the curve ln x, and also the x-axis and the line x equals to c, and the line x equals to e. So the best way to actually approach these type of questions would be to first sketch out how it roughly looks like on the GC, right? So if you take a look at your GC and you key in the graphing function, right, you can see that ln x is somewhere over here, right? This is y equals to ln x, and over here this is the x equals to e portion. So we can see that we are trying to find the volume generated when it's rotated about the x-axis. Now this is the region bounded by the curve, which is this yellow portion, the x-axis and the line. So the first thing we need to figure out is what is this x coordinate over here, and it's fairly straightforward, right? You just need to let y be 0 into this equation over here, and you will solve that x equals to 1, so that over here we know this is 1. So we know that the upper limit is e, lower limit is 1, and we are just trying to find this and then rotate it about the x-axis. So how do we integrate this? So over here we'll write the volume would therefore just be an integral of upper limit, lower limit, right? And then it'll be pi r squared. So where is our r squared over here? So we can see that my r squared is essentially my equation, which is ln x squared dx. Then of course I can take out this over here and I have ln x squared dx over here. But how exactly do I integrate this? So if you see in your first portion, you have no clue as to how to integrate this yet, right? Because this is ln x, but this is ln x squared. So the trick to this would be to recall that in integration, you learn this technique called the integration by parts, which is that it's an invisible one that is written over here, which we usually don't write. And this is under your algebraic portion, whereas this over here is under your logarithmic portion. And then you remember this over here, right? You have A and you have L. So since L comes first and the A comes after that, this will be my U and this will be my V prime, which means that for the first portion over here, we will actually integrate the 1. So we'll have x ln x squared minus. Now for the next portion, we will differentiate the ln x squared. So differentiating the ln x squared over here, I bring down the power 2, right? I minus 1 to the power, and then I differentiate whatever's inside, which is 1 over x. But don't forget, after that, you still need to copy your answer for v over here, right? Because this is u. So this is u prime, but v still has to be here. And in this case, v is just my x over here, dx, and then I close the bracket. So all in all, when I further simplify this, I get x ln x squared minus the integral, and then you can see that this 1 over x and this x actually cancels out. And in the end, here we are just left with 2 ln x dx over here. So we can then further simplify this and use our part A answer. Why? Because in part A, we actually learn how to integrate ln x, right? You see over here, if we differentiate this over here, we get this. So therefore, when we integrate this, we will get back to this. So we can just re-quote the answer that we have above, which means that when we integrate minus 2 ln x, we are just integrating 2 bracket, and then we re-quote our answer above, right? X ln x minus x over here, close the bracket, and then my upper limit will be e, lower limit will be 1. And from here onwards, it's just subbing in the values of e and 1. And eventually, when you sub in finish everything, you'll get a final value of pi bracket e minus 2. And of course, you can just times in the pi to get e pi minus 2 pi units cubed to the final answer over here. So this portion is actually a little bit complicated because it requires you to know that you need to use part A, but they never explicitly say it. That's why it's very important to intuitively recall what you did in the previous portions, because somehow they are linked to one another in some ways. Now for the last portion over here is actually very straightforward. They want us to find the volume generated when R is rotated 360 degrees about the y-axis, and it's to 2 decimal places. That means since it's to 2 decimal places, we can use our GC to directly compute the value. We just need to have the correct equation to begin with. Now with respect to the y-axis, how does that look like? That means we are asking ourselves, what is the area of this purple color region when we rotate it 360 degrees about the y-axis. So you can kind of imagine it, right? It's just taking the entire portion over here, which is just pi r square h, minus away this portion over here, right? Because pi r square h will give us the volume of the entire cuboid. It will give us the volume of the entire cylinder, right? Whereas this over here is the h, and then this is my r, and then over here, when I rotate it here, we'll have another r, right? So you can imagine a circular base and a height. And then we are just minusing away this green portion when we rotate it over as well. That will just give us the purple portion left. So for part C, it's all about just making sure you write the equation properly. But first thing is we need to establish what is our upper limit and lower limit. So my lower limit is 0 over here. What about my upper limit? We can see that over here, right, x equals to e. So when we sub x equals to e into the equation over here, we see that y equals to ln e, which is just 1. So we know that the upper limit over here is just 1 as well. So to find the volume of this is actually very straightforward. We just need to find our pi r square h. So my r is up until e, so it's just pi e square, and then my height is 1, right, h. Then I minus away the integral of the green color portion over here when the volume is rotated about the y-axis. So my upper limit is 1, my lower limit is 0, this is pi, and now since it's against the y-axis, we need to make sure that our variable is with respect to y. So recall that the equation is y equals to ln x. So if I want to make x the subject, it will be x equals to e to the power of y. Therefore, inside over here, I will make it e to the power of y square because it's with respect to the y-axis now, right? So just take note of this very, very crucial distinction. And when you key this whole equation into your GC to get 2 dP, you get a final value of 13.818 units cubed to 2 dP as stated by the question's requirement. So therefore, this is the answer to paper 2. Therefore, this is the answer to question 7 in paper 1 H2 math. Now, this question over here, the first part is all about foot or perpendicular. And the context is that we have a plane, we have a position vector. So the best advice that I have for vectors is to always just draw out the plane or whatever thing that you can try to visualize it. So let's see. We have a plane which is pi 1. 2x plus y plus 3z is 2. So over here I can infer that the scalar product form of the plane is 2, 1, 3 dot xyz is 2, right? Or I can write it as xyz dot 213 is 2, which means r bar dot 213 is 2. That means that I have a plane whereby I have a normal vector. So this is my plane pi 1. My normal vector is 2, 1, 3. And any point on the plane will have a position vector of r, right? So if I sub in this position vector into here, the dot product of these two will give me 2 over here, right? So it doesn't matter if it's here, it doesn't matter if it's here, it doesn't matter if it's here. As long as the point is on the plane, when I sub in the position vector of that point into the scalar product form of the plane, the final product here will be 2 always. The final product will always be 2 always, because the 2 over here essentially kind of measures how far the plane is away from the origin, right? You can just think of it that way. So now, I have a point which is a additional point which is P, and this P does not lie on the plane, right? And I know that this part is a little bit cut off, but here is negative 3, 1, 0. So you can imagine that I have a point P over here. This is P. And the coordinates of P is negative 3, 1, 0. So over here we can infer that OP is negative 3, 1, 0 over here, right? So how exactly do we find out what is the position vector of the foot of the perpendicular called N over here? So I'm just going to let N be the foot of the perpendicular from P to pi 1, right, which is the plane. So the trick over here is as such, right? We can kind of visualize it as an intersection between a line and a plane, because we know that this point over here is definitely parallel to the normal, right? The normal, the direction vector of this normal is definitely parallel to this line. So we can therefore form an equation of another line, which we're going to call L over here, whereby the L and the plane intersect at the point N. So I'm just going to write it and present my answer like that. So I'm going to let L be the line that passes through P and N, right? P and N. So I know that L has an equation of r bar equals to, now I just need a coordinate of one point that lies on the line, so in this case it will be p, or rather the position vector of p, so minus 3, 1, 0, plus, then this is the scalar multiple times the direction vector. So what's the direction? We know that this vector is parallel to the normal, so it will be 2, 1, 3, whereby this scalar multiple is a real constant. So since n lies on the line, we can say that ON, right, ON equals to minus 3, 1, 0 plus this scalar multiple for a unique value of the scalar multiple. So over here we're just going to say for a unique value of the scalar multiple. So we can then actually combine this to give us negative 3 plus 2 scalar multiple, 1 plus scalar multiple, and 3 scalar multiple over here. So we know that ON has, these coordinates, but it's for a very specific value of the scalar multiple. So how exactly do we find this specific value of the scalar multiple? All we need to do is to sub back into the equation of the plane, because fundamentally n lies on the plane. So over here I'm just going to say sub ON into the plane equation one more time. So I'll have ON dot 213 will give me 2 as well. So over here I have minus 3 plus 2 scalar multiple, 3 scalar multiple dot 213 equals to 2. And now when you further expand this equation, you realize that it becomes very beautiful, right? You can actually just solve for the scalar multiple immediately. And from here, when you solve for the scalar multiple, I'm just going to run through I'm just going to skip through the multiplication step. You will solve that the scalar multiple is half. So when you get such a nice value like this, you can rest assured that it's probably correct, right? And now all we need to do is to find out the actual, and all we need to do right now is to find out the actual position vector of n, of ON. So therefore, we just need to sub this back into here, right? So therefore, ON would be minus 3 plus 2 times half, 1 plus half, and 3 times half, right? And therefore, the final answer to this would be negative 2, 1.5, 1.5 over here. And that's the final answer to the first portion over here for A. Now, moving on to B, right? We want to find the position vector of the reflection of the plane P, and we want to find the position vector of the reflection of P in the plane. So what that means is that you can imagine that here is the plane. So I'm just going to draw the plane over here. P is here, N is here, right? Now we know the coordinates and we know the position vectors of both. And we want to essentially find out where is P prime, which is the opposite of P in the plane. So this is a very classic case of ratio theorem, because we know that the distance between Pn and the distance between Np prime will be the same, because they're just reflections of each other in the plane. So we can therefore use the ratio theorem. So over here is my origin is somewhere here, right? And then I can draw a line from here to here, like that. And I can say that first and foremost for part B, I can let P prime be the reflection of P in the plane. So I know that ON is the sum of these two divided by 2, right? So OP plus OP prime divided by 2. Then from here, I just sub in the values that I already had. So over here is minus 2, 1.5, 1.5 equals to, then initially the value of OP is a value of minus 310 plus OP prime divided by 2. So all I need to do to solve for OP prime is just 2 steps. Right, I multiply the 2 over, so here is minus 2, 1.5, 1.5. Then I minus away the minus 310 over here to get OP prime. And then of course, if you do your final calculations for this, you'll get a value of minus 123 over here. And I also just realized that, take note, for part A, your answer should be a coordinate. So here's 1.5, 1.5 over here, right? Because as what the question stated, they want the foot of the perpendicular, which is the coordinates. But for part B, they want the vector. So the final vector would be this as the final answer to part B. Now for the last part over here, it's actually fairly straightforward. We have 2 planes fundamentally, because we have the first plane which we use in the first portion, so plane pi 1, and now we have plane pi 2. And we just want to find the acute angle between these 2 planes. So how exactly do we do that? The idea behind it is something like this, right? So this is for part C over here. So the angle between 2 planes, you can sort of imagine it like this, right? So imagine this is a plane here, so this is pi 1, and then this over here is pi 2, right? Pi 2. Now imagine the normals are like that, right? So the normal of plane 1 is here, right? This is the normal of the first plane, and then this over here is the normal of the second plane. And we essentially want to find out what is this angle over here, which is the angle between them. And essentially what we want to find is to find out what is the angle over here between the two planes. Now, the angle over here is actually the same as the angle over here, right? And I'm going to illustrate to you why. Okay, so imagine this. Okay, so this is pi 1, and I'm just going to draw another over here, and this is pi 2, right? So imagine this, right? If I rotate this like that, right? If I just rotate it like that, this angle over here is going to be the same as how much initially the normal, which is pointing here, rotates, right? These two angles over here are the same. This angle and this angle are the same, because if you rotate it like that, the amount of change is going to be the same for both points. Therefore, the angle between the two planes is essentially the angle between the two normals. You can just think of it that way. So to find the angle between the two normals, we need to first figure out what's the two normals, right? We know that for plane 1, the normal of plane 1 is essentially what we found earlier, which is 2, 1, 3. Now for plane 2, what is the normal of plane 2? How we do that is we need to do our cross product, because over here, the question actually gives us two vectors that are not parallel to each other that lie on the plane. So to find the normal, we just need to do the cross products of these two. And all we need to do is to do the cross product of 2 minus 1, 5, 2, 2, 3. And essentially, we'll get a value of negative 13, 4, 6. So therefore, the angle between the two different planes is just the cosine inverse, right? We call your dot product. And since it's an acute angle, we must make sure that the entire value is positive, and therefore we put a modulus in the numerator as well. So this one will be n1 dot n2 over modulus of n1 modulus of n2, right? And of course over here you just need to sub in the values. So you sub this one into here, you sub this one into here, and then you sub this one into here, you sub this one into here, and when you key the final answer into your calculator, you get a final value of 85.9 degrees to 1 dp. But of course you can leave it in radians as well. And all in all, this is the answer to this question over here. I know that this is a long video, but I hope that you are fully clear on how to tackle vectors question like this, and I hope that it really gives you an insight onto vectors. So let's take a look at this question over here, right? We have y equals to sine inverse px. Now, if you take a look at your formula sheet, you know that when you differentiate d over dx, right? When you differentiate sine inverse x, you eventually get something that looks like this, right? 1 minus x squared over here. Now, of course, this is not wrong, but the thing is that in your question, your final answer is still a trigo ratio. So ideally, when we differentiate, we would want the product to be a trigo ratio and not an algebraic expression, right? Or algebraic fraction. So my first step would actually be to first simplify this, right? I'll actually bring this sign to the other side, and I'll have sine y equals to px over here. Then from here, I would then differentiate both sides, right, with respect to x. So differentiating both sides with respect to x. On the left side, right, differentiate sine, I get cosine. So cosine y dy dx equals to p. Then I would divide the cosine y to the right hand side. So I get p over 1 over cosine y, and you realize that 1 over cosine y is essentially secant y, and that's how we show it over here. So J1 students, beware, right? Even though, yes, technically speaking, you can differentiate sine inverse, but the thing is that, you know, if you are going to go down that route, then later on you will need to construct your right angle triangle to actually derive secant y. It's certainly not impossible, but it's just going to be a lot more steps, right? And for just 2 marks like that, I would probably want to take the shorter route, right? For B, over here. Now, using the differentiation result in A, find the Maclaurin series for y up until x cubed. So we know in Maclaurin series that, you know, the equation y can be written as your f0, right? F prime 0, and then x plus f prime prime 0, x squared, plus, and then you have, then this is over 2 factorial, and then this is f3 0 over 3 factorial x cubed, right? So far, we have our y, we have our dy dx. So for this next portion over here, given that it's 5 marks, we still need to find our d square y dx square and d cube y dx cube, right? So we're going to use our results over here to actually derive that. So from A, we know that dy dx is p secant y. So d square y dx square will be as simple as just differentiating this, right? When you differentiate secant, you get secant x, tangent x. So here will be secant y, tangent y. and then of course over here you need to put your dy dx, right? And then eventually you get p times your dy dx times secant y tangent y, right? Then now you do your d cube y dx cube. So now you need to differentiate this, and differentiating this got 3 terms. So how exactly do you differentiate something that has 3 terms? So this is chain rule multiplied. I didn't cut out the part that I always stumble. So this is chain rule applied to 3 different products all at once. And when it's 3 different products all at once, you can still use chain rule, right? For example, d over dx x y z, right? For example, you will have x y z prime plus x y prime z plus x prime y z, right? You just differentiate one, keep the other 2. Then you apply this throughout all 3, so you have 3 different pairs at the end. So to differentiate this, first and foremost, I know my p over here is the constant, right? It's a scalar multiple. So I open up the huge bracket over here. So now I know that this is my first term, this is my second term, this is my third term. So my first pair will be dy dx times secant y. Now differentiating tangent, I get back secant square y, but don't forget to put my dy dx over here, right? This is my first pair. Now what is my second pair? My second pair would be to differentiate the middle term, so it's my secant y. So I keep my dy dx. Now I differentiate secant y, I get back secant y tangent y, right? And then don't forget over here you still have your dy dx. And then of course you still have to keep your tangent y over there. Last but not least, you go to the first term. So differentiating dy dx, I get d square y dx square. And then over here, I keep my secant y tangent y. So all in all, when you simplify this, you end up with d square dy dx square. So dy dx square times secant cube y. Plus, over here, you end up with dy dx square secant y tangent square y. And then over here, you end up with d square y dx square secant y tangent y. And then you close the bracket over here. So now you have all these 3 different derivatives. And all you need to do is to just sub the value of 0, x equals to 0, and find out what is the value of each, right? So for instance, let's say when I sub x is 0, what do I get? My y, I get it as 0, right? You can just punch this into your calculator. And given that y is 0, you know that this value over here will be 0, right? So when you sub p times secant 1, you eventually get a value of 1. So dy dx is just p times 1, which is just p. Then you repeat the process for d square y dx square, you get that it's 0 over here. And then last but not least, your d cube y dx cube, you get a final value of p cube over here, right? So you just repeat this whole entire process. It's rather lengthy, so I just jump right into it, right? So you get a final value of p cube. Then therefore, to sub the final values into the equation, you get y equals to 0 plus px plus 0x squared plus p cube over 3 factorial x cube, right? And since it's up until x cube only, you do not carry on after that, so you plus dot 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 dot. And therefore, we conclude our answer as px plus p cube over 6x cube as the final answer to part B over here, right? So that's the final values over there. Now for C, they want us to use our answer to find the series expansion of this. And since it's a hence portion, we actually need to start from part B's answer. So how do we actually tackle part C over here? So in part B, right, I'm just going to write the answer at the top over here. We know that y can be written as px plus p cube over 6x cube, right? And our y over here is essentially just sine inverse px. So sine inverse px, when written in Maclaurin series, can be written as px plus p cube over 6x cube. So therefore, in order to do part C, there's 2 steps to this, right? First and foremost, we need to let p equals to 3. And secondly, we need to differentiate it. So to tackle part C is actually relatively straightforward. I'm just going to write the answer over here. So I'm going to let p equals to 3. And I get sine inverse 3x equals to 3x plus 3 cube over 6x cube plus dot 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 dot. Then of course you can simplify this to give you 3x plus 9 over 2x cube plus dot 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 dot. Then in order to get to this equation over here, I just need to differentiate, right? So differentiating both sides. So from here to here, I'm just going to put a caveat over here, which is a differentiating both sides with respect to x. I get a final value of 1 over root 1 minus x squared equals to 3 plus 9 over 2 times 3x squared. And therefore, the final answer to this is 27 over 2x squared as the final answer to part C over here. Now, let's just jump right into this question over here. So given a function, they want us to sketch the graphs, right? And it's also stated that we should include equations of any asymptotes and so on and so forth. So what is the mental model to actually figure out what are the asymptotes? First thing to note is what is the degree of the function, right? Since it's an algebraic function, right? You can see that the numerator is a degree of 1 and the denominator is a degree of 1. So whenever we want to sketch any graph, right, the best thing to do is to actually make this the most simplified version first. So before I actually do anything, I will go and do long division on this to make it as simple as possible. So how do I do long division on this? It's very simple. I just put 4 minus ax, then over here is x plus b. So 4, or rather I can rewrite this as minus ax plus 4, right? So minus ax divided by x gives me minus a, minus ax minus ab over 4 plus ab. So eventually I get something that looks like this, right? When I further simplify this, this can also be written as minus a plus 4 plus ab over x plus b over here. So this over here is my so-called simplified version. But writing it in this way actually allows me to figure out what is the asymptotes so much easier, right? And I'm going to show you why. So over here we can see that when x approaches negative b, right? When x approaches negative b, this whole thing over here will approach 0. And when it approaches 0, it becomes undefined, right? And therefore the graph will become will tend towards infinity. And therefore from here we can tell that x equals, or rather we can say that y, it tends towards plus minus infinity, right? It will go up towards infinity or downwards towards infinity because it cannot, the denominator cannot be 0. And therefore we say that x equals to negative b is my vertical asymptote. Next, when x approaches plus minus infinity. So now you imagine, right, when you stretch along the x-axis from plus minus infinity, you realize that this entire fraction almost becomes 0, right? It tends towards 0. And why does it tend towards 0? Because the denominator over here will become extremely huge, right? And when it becomes extremely huge, this whole entire fraction over here becomes negligible. So we can say that y overall will tend towards negative a only, because this whole thing here will tend towards 0, right? And therefore we know that y equals to negative a is my horizontal asymptote. Now, last but not least, now you know the vertical asymptote, you know the horizontal asymptote. What's left is to just see what is the shape of the graph like. So how do you figure out what's the shape of the graph like, right? You can simply just key this whole thing into your GC and just sub some certain values for a and b first, right? And then you realize when you key this into your GC, you get a graph that looks something like this, right? You get a graph that looks something like this, right? Something like a reciprocal graph like that. So from here, it's very easy for you to sketch out the graph because now you know the shape and you know what's the asymptotes. So very simply put, you can just draw a y-axis, x-axis, something like that, right? You know that your horizontal asymptote is here, which is your x equals to negative b, and you know that your vertical asymptote is somewhere here, right? Which is y equals to negative a. Then all you need to do now is to just sketch the graph, right? One down like that, and then from top down like that, right? And then from here, you can see that there's two intercepts, x-intercept, y-intercept. And how you do that, you just sub x equals to 0, you sub y equals to 0, right? So when x equals to 0, you get 0, 4 over b over here, right? And then when y equals to 0, you get 4 over a, 0. So that's the final answer to the first part over here, right? It's just sketching of the graph. Now, with that said, let's look at part B over here. They want us to describe a sequence of transformations that will transform the graph onto this over here. So the best way to actually approach this would be to use your simplified form, right? And you know your simplified form over here is essentially negative a plus 4 plus ab over x plus b. And now you need to transform this to give you 1 over x. Now, whenever it comes to transformations, right, I typically do not advise people to memorize the order, right? Just do it in a way that makes sense to you. Like, it's just common sense, right? First thing is I would actually get rid of this. So this is the first one, right? When I get rid of this, you know, then the whole thing is just gone, right? Now, the second thing is that I'll get rid of this, right? Once I get rid of this, it becomes 1. Then essentially I have 1 over x plus b. And then the last thing I'll get rid of is this, right? When I do it in this order, you realize that everything just falls nicely in place, right? So how do I get rid of the first one? To get rid of the first one, you are essentially replace y with y minus a, right? Because when you replace y with y minus a, the minus a on the left side will cancel out the minus a on the right side, right? Because now essentially you have y equals to minus a plus 4 plus AB over x plus b. And then when you replace y with y minus a, you get y minus a equals to minus a plus 4 plus ab over x plus b. And then you realize that these two actually cancel each other out. So how do you actually do this? When you replace y with y minus a, you are shifting the graph upwards by a units. You're shifting the graph upwards by a units. So for this first part over here is just translate by a units in the positive y direction, right? Now for the next one, now that you're done with the first step, what's the second step? The second step is to actually get rid of the 4 plus ab, right? So now you have y equals to 4 plus ab over x plus b. So how do you do that? On the left side, you actually need to have a 4 plus ab over here, right? Then y equals to 4 plus ab over x plus b, so that these two can cancel each other out. Now, how do we actually cancel them each other out, right? How do they actually cancel out? Then this is where you will scale parallel to the y-axis by a scale factor of 1 over 4 plus ab, right? Because now you're dividing away the multiple of 4 plus ab. So eventually you end up with y equals to 1 over x plus b. So how do you convert this to y equals to 1 over x? You need to replace x with x minus b, right? You need to replace x with x minus b. So how do you replace x with x minus b? This is where if you recall in your translation, you need to translate the graph by b units in the positive, right, x direction. And that's how you eventually get the final answer to part B over here. Now for part C, they want us to find the range of f inverse x and state. They want us to find the equation of f inverse x and state its range. So again, this is a function question in a graphs and transformations question. So they can be, as you can see, they can test many different topics all in one video. They can test many topics all in one question over here. So how do we actually tackle part C over here? So we have fx equals to minus a plus 4 plus ab over x plus b, right? We are just going to use the simplified form because it's so much easier to manipulate this way. So I'm just going to let y equals to minus a plus 4 plus ab over x plus b. I shift the a over, I get this, right? And then I will times this whole thing here to the right side, to the left side, and I'll divide this whole thing over here to the right side. So they swap positions. And here I get x plus b equals to 4 plus ab over y plus a. And then last but not least, I will minus the b over, right? Minus b plus 4 plus ab over y plus a. So therefore, we can say that f inverse y equals to negative b plus 4 plus ab over y plus a. And therefore, f inverse x will be negative b plus 4 plus ab over x plus a. So that is the equation of the inverse function, right? And they want us to state the range. So we know that the range, right? The range is essentially the output. So the output of the inverse function is essentially the input of the normal function, right? Because they are just complementary of each other, right? They are literally quite the opposite of each other. And looking at this entire graph over here, right? We can see that the domain of the normal function is all the real values of x except for negative b. So over here we can say that it goes from negative infinity up until b, right? And from b all the way until positive infinity. And that's the final answer to this part C over here. And now last but not least, we have part D over here. So part D is given to us that b given that b equals to a. Find the value of the composite function when x equals to 2 and given your answers in a. So for this, there's actually a pattern, and this is one of the most common functions questions out there. So beware of this, right? Look at this. If b equals to a, right, you know that your function fx can be written as 4 minus ax over x plus a now, right? Or it can be written as your negative a plus 4 plus a squared over x plus a, right? I'm just replacing all of the b's with the a's. And then for your inverse x, right, it can be written as negative a plus 4 plus a squared over x plus a. So we realize that when b equals to a, these two are now the same when b equals to a. And given that now these two are the same when b equals to a, we can say that fx is the same as f inverse x, right? That means the rule is the same, which means that f2, or rather f2 x equals to x, right? I apply the function on both sides, right? Apply f on both sides, I get this. So therefore, for f2025x over here, right, we can simplify this to give us f2023x, right? Because the function will repeat itself every multiple of 2. And then this one is the same as f2021x, and then of course you go all the way down and you repeat all the way, right? Eventually you reach the point where you just get f1x over here, and then you realize that the pattern cannot repeat again because 1 is not a multiple of 2. So it's the same thing as fx, and they want us to find the function value when x equals to 2. So when x equals to 2, you get f2, and therefore you get minus a plus 4 plus a squared over 2 plus a as the final answer to this entire question over here. So let's see, we have a plane which is pi 1. 2x plus y plus 3z is 2. So over here I can infer that the scalar product form of the plane is 2, 1, 3 dot xyz is 2, right? Or I can write it as xyz dot 213 is 2, which means r bar dot 213 is 2. That means that I have a plane whereby I have a normal vector. So this is my plane pi 1. My normal vector is 2, 1, 3, and any point on the plane will have a position vector of r, right? So if I sub in this position vector into here, the dot product of these two will give me 2 over here, right? So it doesn't matter if it's here, it doesn't matter if it's here, it doesn't matter if it's here. As long as the point is on the plane, when I sub in the position vector of that point into the scalar product form of the plane, the final product here will be 2 always. The final product will always be 2 always, because the 2 over here essentially kind of measures how far the plane is away from the origin, right? You can just think of it that way. So now I have a point which is a additional point which is p, and this p does not lie on the plane, right? And I know that this part is a little bit cut off, but here is -3, 1, 0. So you can imagine that I have a point p over here. This is p, and the coordinates of p is -3, 1, 0. So over here we can infer that OP is -3, 1, 0 over here, right? So how exactly do we find out what is the position vector of the foot of the perpendicular called n over here? So I'm just going to let n be the foot of the perpendicular from p to pi 1, right, which is the plane. So the trick over here is as such, right? We can kind of visualize it as an intersection between a line and a plane, because we know that this point over here is definitely parallel to the normal, right? The normal, the direction vector of this normal is definitely parallel to this line. So we can therefore form an equation of another line, which we're going to call L over here, whereby the L and the plane intersect at the point N. So I'm just going to write it and present my answer like that. So I'm going to let L be the line that passes through P and N, right? P and N. So I know that L has an equation of r bar equals to, now I just need a coordinate of one point that lies on the line, so in this case it will be P, or rather the position vector of P, so -3, 1, 0, plus, then this is the scalar multiple times the direction vector. So what's the direction? We know that this vector is parallel to the normal, so it will be 2, 1, 3, whereby this scalar multiple is a real constant. So since n lies on the line, we can say that ON, right, ON equals to -3, 1, 0 plus this scalar multiple for a unique value of the scalar multiple. So over here we're just going to say for a unique value of the scalar multiple. So we can then actually combine this to give us -3 plus 2 scalar multiple, 1 plus scalar multiple, and 3 scalar multiple over here. So we know that ON has, these coordinates, but it's for a very specific value of the scalar multiple. So how exactly do we find this specific value of the scalar multiple? All we need to do is to sub back into the equation of the plane, because fundamentally n lies on the plane. So over here I'm just going to say sub ON into the plane equation one more time. So I'll have ON dot 213 will give me 2 as well. So over here I have minus 3 plus 2 scalar multiple, 3 scalar multiple dot 213 equals to 2. And now when you further expand this equation, you realize that it becomes very beautiful, right? You can actually just solve for the scalar multiple immediately. And from here, when you solve for the scalar multiple, I'm just going to I'm just going to skip through the multiplication step. You will solve that the scalar multiple is half. So when you get such a nice value like this, you can rest assured that it's probably correct, right? And now all we need to do is to find out the actual, and all we need to do right now is to find out the actual position vector of ON. So therefore, we just need to sub this back into here, right? So therefore, ON would be minus 3 plus 2 times half, 1 plus half, and 3 times half, right? And therefore, the final answer to this would be negative 2, 1.5, 1.5 over here. And that's the final answer to the first portion over here for A. Now, moving on to B, right? We want to find the position vector of the reflection of the plane P, and we want to find the position vector of the reflection of P in the plane. So what that means is that you can imagine that here is the plane. So I'm just going to draw the plane over here. P is here, N is here, right? Now we know the coordinates and we know the position vectors of both. And we want to essentially find out where is P prime, which is the opposite of P in the plane. So this is a very classic case of ratio theorem, because we know that the distance between Pn and the distance between Np prime will be the same, because they're just reflections of each other in the plane. So we can therefore use the ratio theorem. So over here is my origin is somewhere here, right? And then I can draw a line from here to here, like that. And I can say that first and foremost for part B, I can let P prime be the reflection of P in the plane. So I know that ON is the sum of these two divided by 2, right? So OP plus OP prime divided by 2. Then from here, I just sub in the values that I already had. So over here is minus 2, 1.5, 1.5 equals to, then initially the value of OP is a value of minus 310 plus OP prime divided by 2. So all I need to do to solve for OP prime is just 2 steps. Right, I multiply the 2 over, so here is minus 2, 1.5, 1.5. Then I minus away the minus 310 over here to get OP prime. And then of course, if you do your final calculations for this, you'll get a value of minus 123 over here. And I also just realized that, take note, for part A, your answer should be a coordinate. So here's 1.5, 1.5 over here, right? Because as what the question stated, they want the foot of the perpendicular, which is the coordinates. But for part B, they want the vector. So the final vector would be this as the final answer to part B. Now for the last part over here, it's actually fairly straightforward. We have 2 planes fundamentally, because we have the first plane which we use in the first portion, so plane pi 1, and now we have plane pi 2. And we just want to find the acute angle between these 2 planes. So how exactly do we do that? The idea behind it is something like this, right? So this is for part C over here. So the angle between 2 planes, you can sort of imagine it like this, right? So imagine this is a plane here, so this is pi 1, and then this over here is pi 2, right? Pi 2. Now imagine the normals are like that, right? So the normal of plane 1 is here, right? This is the normal of the first plane, and then this over here is the normal of the second plane. And we essentially want to find out what is this angle over here, which is the angle between them. And essentially what we want to find is to find out what is the angle over here between the 2 planes. Now, the angle over here is actually the same as the angle over here, right? And I'm going to illustrate to you why. Okay, so imagine this. Okay, so this is pi 1, and I'm just going to draw another over here, and this is pi 2, right? So imagine this, right? If I rotate this like that, right? If I just rotate it like that, this angle over here is going to be the same as how much initially the normal, which is pointing here, rotates, right? These 2 angles over here are the same. This angle and this angle are the same, because if you rotate it like that, the amount of change is going to be the same for both points. Therefore, the angle between the 2 planes is essentially the angle between the 2 normals. You can just think of it that way. So to find the angle between the 2 normals, we need to first figure out what's the 2 normals, right? We know that for plane 1, the normal of plane 1 is essentially what we found earlier, which is 213. Now for plane 2, what is the normal of plane 2? How we do that is we need to do our cross product, because over here the question actually gives us two vectors that are not parallel to each other that lie on the plane. So to find the normal, we just need to do the cross products of these two. And all we need to do is to do the cross product of 2 minus 1, 5, 2, 2, 3. Okay, editor, cut out this part as I do this. And essentially we'll get a value of negative 1346. So therefore, the angle between the two different planes is just the cosine inverse, right? We call your dot product. And since it's an acute angle, we must make sure that the entire value is positive, and therefore we put a modulus in the numerator as well. So this one will be n1 dot n2 over modulus of n1 modulus of n2, right? And of course over here you just need to sub in the values. So you sub this one into here, you sub this one into here, and then you sub this one into here, you sub this one into here, and when you key the final answer into your calculator, you get a final value of 85.9 degrees to 1 dp. But of course you can leave it in radians as well. And all in all, this is the answer to this question over here. I know that this is a long video, but I hope that you are fully clear on how to tackle vectors question like this, and I hope that it really gave you an insight onto vectors. Now let's look at this. So the first part of this is basically a parametric equation, and they want us to find dy dx. So the most basic thing to remember is that your dy dx is your dy d theta divided by dx d theta, right? So you fundamentally need to find what's your dy d theta, and you also fundamentally need to figure out what's your dx d theta. So dy d theta will just be simply to differentiate this, right? And over here you get 20 times negative sine theta minus theta cosine theta over here, right? When you differentiate this, and then when you have your dx d theta, now you just need to differentiate this, right? You get 28 bracket. Now note that I never times in because eventually we'll divide them away, so keeping them outside will be easier to divide later on, right? Here I will get cosine theta, and then here is basically just minus theta sine theta over here, right? And then now we're just going to divide them away from each other. So therefore my dy dx over here will just be 20 bracket minus sine theta or minus cosine theta over 28 bracket cosine theta minus theta sine theta. And then of course you realize that within the brackets itself, these two expressions cannot be further simplified, but 20 divided by 28 can be further simplified to give you 5 bracket minus sine theta minus theta cosine theta over 7 bracket cosine theta minus theta sine theta as the final answer to this question 11 over here, right? So this is the answer to part A. Now moving on to part B, so make sure to watch part A if you have not watched part B already. So now moving on to part B over here, so make sure to watch the previous video on part A if you have not watched it yet. Now for part B, they want us to find out the values of theta at C and D given your answer to 2SF. And for this question over here, right, the context given to us is that C and D are on the same level, and C and D are points where the tangent to the curve is parallel to the y-axis. That means at C and D over here, right, the dy dx is undefined. So since the dy dx is undefined at C and D, how does the dy dx be undefined at C and D? It's only undefined when the denominator equals to 0, right? So a fraction will only be undefined when the denominator is 0. So we actually have to use our earlier answer, which is 7 bracket cosine theta minus theta sine theta equals to 0, right? This is only the case, this has to be the case in order for the dy dx to be undefined. And we get cosine theta minus theta sine theta equals to 0. And then from here, you can't really solve this because there is a theta sine theta and then cosine theta over here. So the simplest way would be to just key this into your GC, right? So from your GC, you get that theta equals to minus 0.86 or 0.86 over here, right? So you can't solve this, but you have GC, so make sure to fully utilize your GC at all times, right? But now you get these two values over here, right? So how do you know which one belongs to C and which one belongs to D? So that is where you realize that in the context, right, C actually happens before D in terms of the x-axis, right? The x value of C is smaller than the x value of D. So you just need to sub this value of theta. So sub the value of theta into x, and you see what are the two x values that you'll get. And one you get 12. And for one value you get 12.289, or the other value you will get 43.711. So obviously you can tell that for the negative version it belongs to the C. So at C, theta is minus 0.86 because the x value is smaller. And at D, the value of theta will be 0.86 because the x value is bigger. So you must always make sure to contextualize your answer. And this leads us very nicely to the third part, which is hence finds the greatest width of CD, and it's simply just taking these two x values minusing away from each other, because this over here is the width, right? So the width of CD is just 43.711 minus 12.289, and you eventually get a final answer of 31.4 meters to 3SF over here. And that's the final answer to this portion over here. Now moving on to the next portion over here, they tell us that the x-coordinate of point A is 28. So we know that if we draw a straight line down over here, this is 28. So how do we find the value of theta at point A? It's fairly straightforward. You just need to let x be 28 over here, right? And you know that the x equation is 28 theta. So 28 bracket theta cosine theta plus 1 equals to 28. And then from here you can just key into your GC, or you can just solve cosine theta plus 1 equals to 0, and therefore, or from here you can just solve cosine theta is 1, and then theta cosine theta is 0, right? And then from GC you can solve for theta directly. So again, once again, this requires you to use your GC to actually figure out what's the answer. And from your GC you get multiple values actually, right? You realize that in the x-intercept you get 0 or pi over 2 or negative pi over 2, right? You realize that you get these three different values that are within the principal value range for this question. But then of course there can only be one value of theta for A, right? And the good thing about this question is that we have the diagram to help us visualize, and you can see that A over here is the max point, right? It's the maximum point. So which also means that out of the three values of theta, we should only pick the value of theta that gives us the biggest possible value of A, that gives us the biggest possible Y value, right? So sub the theta into Y, right? And then you get three different values. The first one you get 40, the next one you get 40 minus 20 pi, and then the last one you get 40 minus 20 pi again, right? Minus 20 pi. So it becomes very apparent to us that at point A, right, the value of theta is 0. So this is for A. And then for B, it can either be these two, right? So for B, it can either be pi over 2 or negative pi over 2 because they both share the same y value over here. And therefore, to find the distance of AB is as simple as just taking the two y values, subtracting away from each other, right? So AB is just 40 minus 20 pi, which is essentially just 20 pi. And then you just key this into your calculator, which is essentially just 20 pi units over here. And that's the final answer to this question over here. All right, and now moving on to the last portion, which is D, right? They want us to know for safety reasons whether the distance AE is within plus minus 10 of the distance of half of CD. So of course, this is like a primary school question, right? You just need to find the length of half of your CD first. So half of CD is just half times the answer that you found earlier on in the earlier portion, which is your answer over here, which is 31.4 ... meters, right? So 31.4 ... meters, and you get 15.7108 ... meters. Now, what is the distance of AE? So AE distance is just the x-coordinate of, is just the y-coordinate of A minus the y-coordinate of E, right? Just subtract these two away from each other. So you know that the x-coordinate of the y-coordinate of A is 40. Now, for the y-coordinate of E, right, how do you do that? You need to first figure out at E, what's the value of theta. Now, you know that theta equals to 0.86 ... over here. Why? Because E is on the same level as C and D, right? Which means they all share the same value of theta when it comes to y, right? So all you need to do is to just sub this value of theta once again into the y-coordinate over here to find the y. All you need to do is to just sub the value of theta into the y equation over here to find the y-coordinate of E. And you will eventually get a final value of 26.956 ... And subsequently, when you subtract these two away from each other, you get 13.0437 ... meters, right? So a very simple way to tackle this question would just be to find out what's the percentage difference. So the percentage will just be 13.0437 ... over 15.7108 dot 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 times 100%, which gives you a value of 83.0%, right? And this, you can see that 83% is smaller than 90%, because when we say within 10% of the distance, that means the maximum range that we have is from 90% all the way until 110%, right? So this 83% actually falls outside of the valid range, and therefore it does not satisfy the answer over here. So I know that this video is rather long, but I wanted to make sure that you can fully understand the concept. Let's just jump right into this question over here. It is given that we have a complex root and one of the root is 1 plus 2i, right? And it fulfills the condition over here where, you know, p and q are real numbers. So we can immediately see then this is a very, very common type of scenario whereby if they tell you that this is real and this is real, and clearly, you know, this is real, and then over here there's a 1, you can see that all of the coefficient, right, of all the terms are real. So since all the coefficient of all of the terms are real, by conjugate root theorem, right, we sometimes call it CRT, the conjugate root of one of the complex roots is also a root, right? So we can immediately conclude that, and that's actually the first part. Okay, so these 2 marks here is actually free. You can just over here part A say that since all the coefficients of the terms in the equation are real by conjugate root theorem, right? Z equals to 1 minus 2i is also a root. And then note that over here, you have to identify what is A, what is B. So we will say that where AA is 1 and B is minus 2, right? And then this is a very free 2 marks. So, you know, complex numbers, especially in the new syllabus, it's actually a lot simpler compared to the previous syllabus because they actually omitted exponential and trigonometric forms, right? So, you know, more or less they can't really test that much anymore, which is a good thing. So make sure your basics just like this are, you know, really dialed in if you want that free 2 marks. Now for B, find the values of P and Q and then find the third root. So now that we know that, you know, we know 2 roots already, and this is a cubic equation. So very, very simply, what we can do is if we want to solve this question as fast as possible, will be to just compare the coefficients. So over here, we know that z cubed plus pz squared plus qz minus 10 is a product of 3 roots, right? Because it's a cubic equation. So the degree here is 3, which means there's 3 roots. So the first root will be z minus 1 plus 2i, right? This is one of the factors. So this over here is the root, and therefore the whole thing over here is the factor. Note that we need to express it as a product of its factors and not a product of its roots, right? Because the roots are the solutions, but it is made up of its factors. So the other factor would be z minus 1 minus 2i. And then the last one, right? So far what we have is that this is the root that we initially were given, and then we got this over here by conjugate root theorem, right? CRT in part A. So in a cubic equation, right, it cannot have 3 imaginary. And why can't it have 3 imaginary roots is because by conjugate root theorem, especially in this context where all the coefficients are already real, right, the conjugate roots must come in pairs. So the roots has to be either 2 roots, 4 roots, or 6 roots, right, depending on the degree of the polynomial. So we know that the last root is actually real, and it will we can just simply write just z minus, for example, b over here. Okay, so we can just write b over here and then close the bracket, where this b over here is the last real root. Okay, I'm just going to bring down last real root, and then the whole thing over here is the last factor, right? As simple as that. And then from here onwards, we just need to expand and then compare the coefficient. So when we expand this, we get z minus 1 minus 2i, z minus 1 plus 2i, z minus b. And then expanding the whole thing, okay, so we just expand the first 2 brackets here first. We'll get z squared minus z plus 2iz minus z plus 1 minus 2i minus 2iz plus 2i minus, or rather it becomes plus 4, right? And then we have a z minus b over here, right? Because for the last expansion, minus 2i times 2i, right? I times I gives me minus 1, and then, yeah. So minus 1 times minus times 2 is 4. So from here, we just simplify this. The iz will cancel out the iz,
and then the 2i will cancel out the 2i here, and then the z squared minus z plus 1, and then here is plus 4. So when we simplify this, we essentially get z squared minus 2z plus 5 bracket z minus b, and then we further simply expand this, we'll get z cubed minus z minus b z squared minus 2z squared plus b plus 2bz plus 5z minus 5b, right? And then we further simplify this and group all of the coefficients together. We'll end up with something that looks like this. So we'll get z cubed bracket or z cubed plus bracket minus b minus 2z squared plus bracket 2b plus 5 bracket z minus 5b, right? Apologies for that. Now we expand this whole thing and then we essentially get this. So from here, it's very simple, right? We just need to compare the coefficients because we know that the constant minus 10 is essentially minus 5b. So comparing our like terms, right? Minus 10 is minus 5b. We get that b equals to 2, right? As simple as that. So the last root over here is actually 2, right? The third root over there. The third root over here would be z equals to 2. And then we just need to figure out what is our q value and p value over here. So we can just sub the values, right? So this is the first comparison. The second comparison would be p equals to minus b minus 2. So we know that b is 2, so b is minus 2, and then p is minus 4, right? So this is another answer. And the last one will be q. So for q, you can see that q is 2b plus 5. So 2b plus 5, we submit the values. Q is 2 times 2 plus 5. Q is 9. So in the end, we get these 3 different values, and that's the pretty much the answers to part B, right? So P is minus 4, Q is 9, and the last, apologies for that, and the last root is Z equals to 2 over here, right? The last root is Z equals to 2. Now note that for the portion where you are supposed to identify the root, right, you have to write the whole thing. You have to write z equals to 2 over here, simply because you are trying to write the solution, and therefore there has to be an equation for the last portion. All right, and therefore that's the final answer to part B. Now moving on to the last one, which is part C, right? Hence, find the roots to the equation 1 plus PW plus QW minus 10 10W cubed. Now for the last portion over here, even though it's just 2 marks, I found that this question was the most well thought out question in the whole paper. Like, it's one of the most least expected questions, because it's not your typical type of questions that you usually encounter, right? So how do we actually tackle part C? This is where, if you think a little bit deeper, right, you probably sense that it's using some sort of substitution method. But the truth is that before you can use the substitution method, you need to actually perform one step, and I'll show you why. So let's start off with the equation that we already have. And the equation would be z cubed minus 4pz minus 4z squared plus 9z minus 10 equals to 0. Right? This is the equation that we have. And what we need to do is that we need to make this to become 1, and I believe it's 1 minus 1 plus, so 1 minus 4w plus 9w squared minus 10w cubed equals to 0, right? So this is the final equation that we need to make our equation to. So in order to get to here, right, it's actually 2 steps. And the first thing that I realized is that if I were to just look at these 2 first terms over here, right, you can see that one gain w cubed, like this one gain w cubed, and then this one, it completely disappeared the z cubed, right? So it actually, what we can do first is to either pick both sides, right? Either one of the sides, right? We can either add the terms first so that we fulfill one side first, or we remove the terms so that we fulfill the other side first. So I'm going to remove the terms first. Okay, so from here to here, I divide z cubed throughout, okay, throughout, so that at least I satisfy half of it first. So I get 1 minus 4 over z plus 9 over z squared minus 10 over z cubed equals to 0. Right, at least I satisfy that first. Then you realize something. You see that here, this z matches the zw over here. This z squared matches the w squared over here. And then this z cube actually matches the w cube over here. So how do we manipulate this in the second step in order to get to where we want to get, right? So this is where the substitution actually comes in. Because if we realize from the second step to the last step, all that needs to be done is to just flip the terms at the bottom to get to the top, right? And how do we actually do this? Is by using a substitution. So substitute z for 1 over w, and you end up with 1 minus 4 over 1 minus w plus 9 over 1 minus w squared minus 10 over 1 minus w cubed equals to 0, and that eventually leads you to this, right? So that is how we actually get to that. So you realize that the way to solve this question will be to just replace the z initially for 1 over w, and that's how you actually get the answer. So therefore, using our earlier answer, right, from our earlier answer, we get that z equals to 1 plus 2i, or 1 minus 2i, or 2, right? So therefore, when we do this substitution, w equals to, then we will just 1 over 1 plus 2i, or 1 over 1 minus 2i, or 1 over 2, right? And then of course you can further simplify this by rationalizing the denominator, so sort of, right, rationalizing the denominator, or you can just key this to your calculator. And then from here, we can just further simplify it, right, to eventually get a, from this over here, we can get a fraction of 1 over 5 minus 2 over 5i, or 1 over 5 plus 2 over 5i, or half, right? And those are the 3 final answers to this question over here. So you can see that this whole question over here, very, very standard, complex number question, but at the same time, it requires some sort of understanding just beyond the surface level, right? Especially when it comes to the manipulation. So with that said, this marks the end of the whole paper 1 2025 H2 Math debrief. Let me know what you think about this paper in the comments below, and as always, feel free to check out the rest of the channel if you want more videos on specific topics and lessons, and also check out the link in my description if you want access to my full library of more questions just like this. Right, if not, that's it. Thanks for watching. I'll see you in the next video.